लो बच्चों, binomial distribution. Binomial distribution is basically this is its base is the probability distribution that you guys have just studied. The probability distribution. In a probability distribution, you can have different sets of outcomes. For example, if you toss a coin two times and you are studying the number of heads, you remember that there can be zero heads, there can be one head, there can be two heads. So that was your x. And then you had probability x equal to x. Through the table diagram, you have seen that this could be 1 over 4, this could be 2 over 4, and this is 1 over 4. When you are throwing a die, rolling a die twice. And you also have seen that the differences, for example, we want to study the differences there, okay? So the differences could be, this is x, probability x equal to x. We remember that the zero difference could be 6 out of the 36 times. And then the difference 1 was 10 out of 36 times. And then the difference of 2 was 8 out of 36 times. And the difference of 3 was that 6 out of 36 times? And the difference of 4 was 4 out of 36 times, and the difference of 5 was 2 out of 36 times. You see the sum has to be 1 here. Let me check. 16, 24. Yeah, this is also 36 over 36. Now you see that these were the situations where here you are having 3 different outcomes, and here you have 6 different outcomes. Okay. If you look at the name of this topic, that is the binomial distribution, what do you get from this binomial, guys? क्या आता है ज़हन में when you look at this word binomial? No response. You have studied a whole chapter binomial theorem in your P1 and in your P3 as well. So what is a binomial?
Sir, any expression that has two terms.
Two terms. And in case of probability, like you see this is a probability distribution which has these 3 different outcomes. This is a probability distribution where you have 6 different outcomes. So what kind of this binomial distribution is going to be if you look at this and you look at the name of this, which says binomial distribution? Yes, Safa? Yeah, this will be dealing with the cases where there are only 2 situations. Can someone give us an example of an experiment where we have 2 outcomes? Yes, Fatima, can you think of any situation where you can have you have an experiment and there are just two different outcomes?
Say rolling a dice.
Yeah, rolling a dice would give you how many outcomes?
2.
2. Are you rolling
4.
a two-faced? Huh?
4.
4. How many faces are there of that die that you're rolling?
2.
Can there be a die with 2 faces? Fatma, I think you're confused. Can someone correct Fatma? What word she had?
Coin toss होगा.
Coin, like tossing a coin would always result into 2 possibilities. Like it can be either head or it can be a tail. Can there be any other situation where you have 2 possibilities? Like for example, you are a PTI, fan, okay, and there is going to be an election. So your party is going to win or it's going to lose, okay? Is it going to be raining today or not raining today? Okay, you're going to pick a ball. Is it going to be a red ball or not a red ball? Like even if you look at these situations here, like if you look at rolling a die, maybe I thought Fatma is going to say that, you see, normally when you roll a die, there are six possibilities. But suppose if you want to have a six, so your situations can be a six or not a six. It can be a six or not a six. This is clearly, these are two outcomes. Okay, suppose there is a lucky draw, okay, and there are 1000 people participating in that lucky draw. So for you, it is going to be a winning or a losing situations, because if you get your name in the draw, so that means you're going to win that, otherwise you're going to lose that. Okay, so anyhow, sometimes it is clearly a binomial distribution, like tossing a coin. Okay, but tossing a coin, but you can transform any experiment into a binomial case. Like when you roll a die, you can simply say, okay, getting a six, not getting a six. Like in this lucky draw, you can say this is winning or it is going to be losing. Okay, acha. Now, so first thing that should be clear to you, that in a binomial distribution, we have clearly two outcomes, okay? Head or tail, winning, not winning, losing, or is it a six, not a six, okay? Acha. Now, first thing, that in a binomial distribution, we have two outcomes, okay? And in this chapter, these would be known as P and Q. That is the probability of success that you want to happen, okay? You want to have a six, that is P, okay? This is the probability of failure, okay? So this P plus Q will always be equal to 1. P plus Q, that will always be equal to 1. You have P, you can get Q, or you have Q, you can get to the P, okay? So this is what we are going to start with. Secondly, bacho, in a binomial distribution, you see a binomial distribution is written like this. Sorry, X is binomially distributed with the parameters N and P. Now this N is basically the number of trials, like how many times you're going to toss a coin, how many times you're going to roll a die, how many days you're going to look for if it's going to rain or not. Okay, so this N is number of trials. This should be given if you want to model your distribution as a binomial distribution. Okay, you must know this probability of success. Okay, this is the probability, writing this again, probability of success. Okay, then if you want to model your distribution as a binomial distribution, then both this P and Q, they should both be independent events. Okay, like if you get a head, this should not affect the probability of getting a tail, or you get a tail, this should not affect, this should not have any effect on the probability of getting a head. Okay, secondly, both of these events should have fixed probabilities throughout. Okay, the probabilities are fixed or they are constant, fixed probabilities throughout the experiment. Okay, it should not be the situation that in the first trial the probability of P was, let's say, 0.8, and in the second trial it is going to be decreased to 0.7, or it is going to be increased. Okay, so this has to be fixed throughout, I mean, the whole experiment. Okay, so if you have if there is a binomial distribution, let me write this again. If X is binomially distributed with the parameters N and P, then the probability that X equal to R is NCR, P raised to power R, and Q raised to power R, N minus R. Let me write this again. This is N minus R. Okay, if you want to understand that what I have written over here, you will have to be responsive. But so I'll explain this only with your participation. Okay. Now, like guys, listen. I'll be telling you about this first part of the formula, this NCR. Okay, guys. Um, for example, I ask you that you are tossing a coin three times. There are three tosses. N is equal to 3. And I want you to tell me that what's the probability of getting one head? What's the probability of getting one head? What do you need to know first of all to give me this probability that we get one head? Yes, please be quick. Laiba, what do you need to know if you want to tell us what's the probability of getting one head? Hmm? Okay, there is no response from Laiba.
Say
Jannat,
how many times we tossed it.
how many times what?
We tossed the coin.
We know that we're going to toss the coin three times. And then how would you answer to this? Aiza, do you have any answer, or Anood or Hafsa?
Sir, P की value, probability of getting ahead.
We know that that is going to be 1 over 2. Okay, then. Acha, I think I should tell you. Guys,
Sir, from 3 tosses, if we want to find the probability of one head, wouldn't we draw a tree diagram showing the 3 possibilities of getting one head and then add them
exactly,
together?
exactly. Who was this? You please tell me your name as well whenever you're like, responding. Who was this?
Sir, Shiri.
Okay, Shiri beta, you are absolutely right. That is basically knowing about the situations and how many times this would be happening that you're getting one head in these three tosses. Okay. Now, one way is that you start listing this. You see, if I like rather than drawing a tree diagram, can I list it like this? That you have a head, then you have a tail, then you have a tail. You have a tail, then you have a head, then you have a tail. Then again, you have tail, tail, and then head. This is how you can have a head in three tosses, one head in three tosses. Do you understand this or not?
Yes, sir.
Yes? Hannah? Acha, this is basically 3 factorial over 2 factorial. Because there are two tails and there's one head. This is 3 factorial over 2 factorial. And writing this 3 factorial over 2 factorial is simpler if you write it as 3C1. That means out of 3 tosses, we have one head. We have one head. Is it clear to you that when we want to know that how many times this is going to head in these 3 tosses, that we can have one head? What are those situations where we can have one head? So this can be head, tail, 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 head, tail, or tail, tail, head. Okay, so these are clearly the 3 cases. These are clearly the 3 cases. Okay, now if you let me write now this here. Okay, this 3 was basically 3 factorial over 2 factorial, or this can simply be written as 3C1. Achha, can I say this is going to be 1 over 2, this is 1 over 2, this is 1 over 2, and then this is going to be 1 over 2 into 1 over 2, 1 over 2 into 1 over 2. Now this time, since getting the probability of both head and tail is same, so that's why I am just changing their colors. So guys, head and tail, half into half into half. Can I write this thing as half into the half square? Can I write this as half into the half square? Can I this also as half into half square? Please tell me if you agree or disagree. This half into half into half, this is half into half square. I'm writing this into half square because of the two tails and then one head. So can I write it like this? Yes, Bacho? Yes?
Yes, sir.
They are all
Yes.
same. Can I say that this half into half square is 3 times here? Yes or no?
Yes,
Yes,
sir.
sir.
Yes. Okay बच्चों प्लीज यार मेरे साथ रहना मुझे डर लगता है यार अकेले बैठे हुए यहाँ पे अब देखो this is going to be 3c1 probability that you get one head is going to be 3c1 the probability of head is half this is half raised to power 1 and the probability of getting the tail is half so this is half raised to power 2 that is how we use this formula 3c1 half raised to power 1 into half raised to power 2 and then you can find this now suppose bacho look at this example let's say you're going to roll a die 4 times n is equal to 4 n is equal to 4 and you want to know that let's say we're going to study the number of sixes okay that is our interest the number of sixes okay so what will be p what is the probability of getting a 6
इसलिए मेरा दिल कर दिया.
probability of getting a 6 is yeah when you roll a die what is the probability of getting a
1
6
over 6.
1 over 6
Number 6,
and what's the probability of not getting a 6
5 over 6.
thank you beta this is 5 over 6 okay now the question is that we have to find the probability that we get 2 sixes x is equal to 2 now through the formula this would be 4c2 this is we want 2 sixes and obviously there will be 2 non-sixes so that is how you will find this let me illustrate this now you can have 6 6 not 6 not 6 you can have 6 not 6 not 6 and a 6 you can have not 6 not 6 6 and 6 and then similarly we can have 6 not 6 and then 6 and not 6 or we can have not 6 is there any other situation Michu? You see listing is so difficult so this NCR saves us from listing is there any other situation Bacho? There is one more situation that is going to be yeah S dash S S dash S so these are the 6 situations है ना और बोलो यार
जी sir.
है ना so these are the total possibilities okay now look at this each one of them will have the probability like this this is 1 over 6 times 1 over 6 and then you have times 5 over 6 times 5 over 6 so since you know this S dash is twice here so you have 5 over 6 twice here you have this S twice over here so you have this 1 over 6 twice over here so these are going to be 6 times 1 over 6 square and then you have 5 over 6 square so that is why guys here you have this this probability that x equal to 2 is 4c2 1 over 6 square times 5 over 6 square so does that make sense to you is there anything on this whiteboard that is not clear to you please be quick to respond if you need help please let me know Okay, so you guys are not asking anything. So that means let me summarize this and we go into the next segment where I'll be taking questions from the past papers. Guys, listen. Uh, the situation is, the thing is, if your X is binomially distributed with the parameters N and P, you see there are different probability distributions that you will be studying in your statistics syllabus. So they have their own parameters. The binomial distributions is defined through N and P, where N is the number of trials which has to be there, okay? P is the probability of success. Okay? अच्छा, तो फिर the probability that X equal to R is going to be NCR, P raised to power R and Q raised to power N minus R. That is the formula that you will be using. Okay, and in this formula, this NCR tells us the number of different possible arrangements of the situations where we can have that, you know, this X equal to R happening. You can see this all this listing is showing you that what are those possible situations where you can have two sixes and two non-sixes, obviously, out of the four throws of a die. Okay, so NCR tells you the number of possible outcomes जिसके अंदर this success is happening R times. Okay, and this is probability that is happening R times P raised to power R, and this is obviously Q raised to power N minus R. Okay, if I show you the questions from the book, you see the questions are here. It says, look at this, these questions. We can try some of them because we have still 7 minutes with us. Okay, now look at this. It says in the first question, it says the variable X has a binomial distribution with N equal to 4 and P equal to 0.2. So the same thing could also be written as that X is binomially distributed with 4, like this could be written as 4 comma 0.2. If it's given like this, then you would say, okay, N is 4, P is 0.2, and you will yourself determine Q, which is going to be 0.8. Then it says, find the probability that X is equal to 4. So that would be 4C4 0.2 raised to power 4 and 0.8 raised to power 0. And then you will use your calculator to find this probability. Okay? Look at the B part. In the B part, it says probability X equal to 0. So that is 4C0 and 0.2 raised to power 0 and 0.8 raised to power 4. You can use your calculator. Now remember this binomial distribution also deals with the discrete number of outcomes like successes. You cannot be asked to find the probability that X is equal to 4.5. This will never be asked, okay? Or you can, if it says find the probability that X is, let's say, minus 4.2. So these are the situations that cannot be asked to you, okay? The R will always be a positive integer, okay? Now look at this, D part. It says probability that X equal to 3 or 4. So you would comprehend it like this: probability X equal to 3 plus probability X equal to 4. So this would be 4C3, and then there is 0.2 raised to power 3, 0.8 raised to power 1 plus 4C4, 0.2 raised to power 4 and 0.8 raised to power 0. And then you will use your calculator to find this probability. Okay, bachcho? So I can show you the solution of one of the parts from the second question. You see in the second question, it says you're given that this y is binomially distributed with the n 7 and p as 0.6. Okay, so this n is 7, p is 0.6. You will yourself write the q, that is going to be 1 minus 0.6, that is going to be 0.4. Okay, so this let me do that B part. It says probability that your y equal to 5. So that is 7c5, 0.6 raised to power 5 and 0.4 raised to power 2. And then you will use your calculator. Look at this D part. It says probability y is between 3 and 6. It means it is going to be probability y equal to 4 plus probability y equal to 5. And then you will use your formula. Okay, guys, so that is it from this session. You can easily try all the questions of this exercise 7a. Okay, you look at these questions here. We are going to come back
Question
to
2C.
solve these questions. Yes, beta? Yes?
Question 2C में does not equal to 4 कह रहे, वो वाला कैसे करेंगे?
Yeah, in this 2C, beta, when it says it's not equal to 4, so this would be 1 minus probability y equal to 4. You will do it like this. Okay? Got it?
जी sir.
Okay, beta. So please come back for the next session.